Hi, welcome to Ivy-GreGMAT Quant Intro Session, AP&GP, Arithmetic Progression and Geometric Progression. I am Arijit Chakravarti. Let's get started. Okay, what is an arithmetic progression? Arithmetic progression is basically a sequence of numbers such that the difference between the consecutive terms is constant. Is constant. How? Let's see further. It is a series of numbers in which every term after the first term can be derived from the term immediately preceding it by adding it to a fixed quantity called as the common difference. So let's take an example. 1, 2, 3, 4 may be a good example. Like 1 is followed by 2, followed by 3, followed by say till 50. Every time I derive the second term, the third term, I am adding up one number, that is 1. 2 plus 1. So I get 3. So I get 2. And then I add up 1 again, I get 4. Like this. Or I put it the other way around. Let's take this second series. 2, 5, 8, 11. This is an AP. Why? If I subtract 5 minus 2, it is 3. This to this. If I subtract 8 minus 5, it is again 3. If I subtract 11 minus 8, it is 3. So the difference is 3. So that's common. That's called as the common difference. So AP is a series of numbers. When I add up one constant term, the series is formed. Right, folks? So this kind of numbers actually comes out with a special type of formula, or rather, the problems are to determine which is the last term, which is the number of terms, what is the summation of the terms. Let's see. So if I put AP in a typical formula form, or I can say the first term is A, the difference is D, then it is A plus D is the second term. The third term will be A plus D plus D. The fourth term will be A plus D plus D plus D. Every time I'm adding up one D extra. So if that is the case, then the series looks like A plus 2D, A plus 3D. So this is the first term. This one is the second term. This is the third term. This is the fourth term. We can even call this as T1, T2, term 2, term 3, or you can call it term 3, term 4. Let me write it properly. T3 or say T4. Just to designate. Now, my question may be that fair enough, it's an AP. What is the nth term, or rather the last term of the series? T, N, or any number of term, say the 26th term, or the 5th term, or the 19th term, or 156th term. We zero down upon something like this, a formula which is like Tn is equal to A plus n minus 1 into t. But how come this formula came? Let's take it in a simpler fashion. If T1, that is the first term, is equal to A plus 1 minus 1 into d, then this becomes A. Remember, we made something like this. Then T2 will become A plus 2 minus 1 into d, which will become A plus d. The T3 will become A plus 3 minus 1 into d, which is A plus 2d. So the term 1 is A, term 2 is A A plus D term 3 is like this. So from this, I can derive something like that. So which says that Tn is equal to A plus n minus 1 means nth term minus 1 into D, which is the common difference. This formula, where A is the first term, D is the common difference, n is the total number of terms, and Tn is the nth term of the sequence. This formula will become pretty handy for us to solve. So need to memorize it to a certain extent. Okay, let's move on to the next type, which is like summation of the n terms in an AP can be given by Sn. We have just designated it, designating it as Sn. So plain vanilla put sum of n terms is actually the total number of terms multiplied by the mean of the set of numbers. If we put it this way, then if this is the situation, then we can do a bit of a further treatment here. We can say this is n into a first term plus t in last term divided by 2. This is the mean. If this is the case, then this is n into a plus tn formula we knew as something like a plus n minus 1 into d divided by 2. So this is the formula. So if I simplify it, it looks better like this. So Sn becomes n by 2 multiplied by twice a plus n minus 1 into d. This is again a bit we'll have to remember this formula, which is actually equal to n by 2 into a plus tn. Having said that, definite question can be, if I want to know the number of terms in an AP, the n of the AP, it is fairly very simple. N term minus t1, the first term, by difference plus 1. Again, one of the very handy formulas. If I want to know the nth term, this is something which is useful. The sum of the n terms is this, or we will be also using n by 2 into a plus tn. Okay, let's do a bit of a summation activity here. Summation, or rather coagulate it into, freeze it into one place. Sum of an infinite AP can never be a finite. So this is for our understanding sake. Except if A1 is equal to 0 and D0 is equal to 0. Then again, the sum of the terms is n by 2 multiplied by twice a plus n minus 1 into d. The formula is derived from the fact that n by 2 multiplied by first term plus last term. We will be coming across questions where we'll be given that all odd positive numbers. So obviously our a will become 1 and d will become 2. Reason being, sum of all odd positive numbers. The first positive number is 1. So the Next number is 3 followed by 5 followed by 7. So I have to remember one thing. A is equal to 1 and B is equal to 3 minus 1. 3 minus 1, which is equal to 2. I may come across a question where all the multiples of 23, 5, 6, 10, 11. So obviously A will become, say if it is 23, the next term, the difference will also become 23, because if I multiply 23 multiplied by 2 multiplied by 3, I am multiplying, the difference will always be 23. Similarly, say it comes as all positive multiples of say 5. So A will become 5 and T will also become 5, because it's 5, 10, 15, 20, like this. Another situation, all negative reals with decimal 0, 1. So again, A1 is equal to minus 0, 1, 0.1, and difference is minus 1. So this is for our understanding sake how it happens. Now, having said that, we from the previous formula we have derived something like this. Let's look at it further. We'll realize it how it is handy. Sum of first n natural numbers. What are natural numbers? First of all, natural numbers are numbers which start with 1, 2, 3, 4. So a basic understanding, natural numbers are positive integers. Natural numbers are positive numbers starting from 1 followed by 2, 3, 4. For our understanding again, what is the whole number? Whole number starts with 0, 1, 2, 3, like this. And an integer is minus, say, 5, minus 4, minus 3, 0, 1, 2, like this. So natural numbers, the moment the word natural number comes in the picture, it is 1, 2, 3, 4. So now the question is the sum of first n natural numbers. So if there are n number of natural numbers, then the sum of n natural numbers will be n into n plus 1 by 2. So sum of n natural numbers, let's take an example. Say the sum of first, let's take an example. First 50 natural numbers. This means it starts with 1, 2, 3, 4, 5 till 50. So if I'm asked to do a summation of this number, believe me, the longer way is pretty pathetic. If I want to add up 2 plus 1 is a 3, 3 plus 3 is equal to 6, 6 plus 4 is 10, 10 plus 5, 15. I mean, this is ridiculous. So, smarter way, sum of n natural numbers is n into n plus 1 by 2, which is 50 into 50 plus 1, 51 by 2, which is equal to 25 into 51, which is equal to whatever. Fair? It makes our life easier. So again, another formula. The first n natural numbers, pretty much handy, this kind of a formula. The sum of first n odd natural numbers. N odd natural numbers. That means if I look at this, natural number means 1, 2, 3, 4, like this. N odd natural numbers will become 1 followed by 3 followed by 5 followed by 7. So the first n odd natural numbers will be, say, let's take another example. Say n is equal to 26. That means it is 1, 3, 5, 7 till the 20 till the 26th number. Now you shouldn't say that it is till 26. Obviously 26 is an even number. Till the 26th number, whatever it may be. So the summation of these numbers is the question here. If that is the thing, then if n is equal to 26, the sum will be n square, which is 26 square. Let's take the third one. The first n even natural numbers. So again, we know 1, 2, 3, 4 are natural numbers. The even natural numbers will be, the first one will be 2, followed by 4, followed by 6, followed by 8, 10. The sum of first n even natural numbers. So if I go on and if I'm asked, say, till the 50th natural number, what is the summation? First n even natural numbers. Let's add it up. How it happens? The formula is n into n plus 1. How come? Then the answer becomes 50 into 51. Because this is 50 multiplied by 50 plus 1. Let's take third element, fourth one. The sum of squares of first n natural numbers. So if natural numbers are 1, 2, 3, 4, it is 1 square plus 2 square plus 3 square plus 4 square, and the story goes on. So if I am asked the squares of first n natural numbers, say let's take till 10. If I want to make a summation of this, the formula will be n into n plus 1 multiplied by twice n plus 1 divided by 6, which is equal to, n here is 10, 10 into 10 plus 1, 11 multiplied by 20 plus 1, 21 divided by 6. Now we can do a treatment, whatever will be the answer. Similarly, cubes of first n natural numbers. Again, we'll just fit in the name number. It will become n into n plus 1 by 2 the whole square. Just for our understanding sake, for making our calculation easier, just do remember these. That's why this slide is there. Anyway, let's do some real-time exercise. We'll learn it better. We'll cement our understanding. Question number 1. Find the number of terms in a series. That means Tn in a series, which looks like this: 3, 4, 5 till 21. So the series starts with this number, ends with this number. So the first term a is equal to 3, or T1 is equal to 3. Tn is equal to 21. What is the difference between them? So this is the first question. D is the common difference is 1. We know the number of terms n is equal to Tn minus T1 by D plus 1. 21 minus 3 divided by D, that is 1 plus 1. This is 18 plus 1 is equal to 19 is the answer. So the number of terms in a series which starts with 3 as the first term and ends up with Tn is equal to 21 with a difference of 1. Since we can see the difference is 1, the total number of terms is 19. Let's take the next one. The sum of first n positive integers. So fairly very simple. Straight Sn is equal to n by 1 second, n by 2 multiplied by twice a plus n minus 1 into d, or we can say fairly very simple, number of terms into their mean. First n positive number, n into n minus 1 by 2. Clear? We learnt it, the formula. Here is the place. This is the second question. So let's go for the third one. The sum of first 50 positive integers. 50 positive integers. So n here is 50. Sum of n positive integers is sum of n natural numbers only. So same formula, 50 into 51, n into n plus 1 by 2, which is, let's do it, 25 into 51. If I do a calculation, it will become 1275. Well, let's take the fourth one. Sum of all integers between 40 to 100 inclusive means the set number looks like this: 40, 41, 42, 43 till 100. So including this and this number. That's what inclusive is talking about. But we have to find the sum of all the integers between these numbers. So let's take this calculation. Let's do it here. Fourth one. In this case, a is equal to 40, Tn is equal to 100. Then Sn is equal to n by 2 multiplied by a plus Tn. Where number of terms, so we'll have to find out n here, which is unknown, of terms is equal to, or rather n is equal to Tn minus a plus 1. The total number of terms, this is the formula. So 100 minus 40 plus 1, which is 60 plus 1 is equal to 61. If that is the case, this is what we found out. Let's fix it in the formula. Sn is equal to this one, 61 by 2, a being 40 plus 100, which is 61 by 2 multiplied by 140. This is 61 into 70. Well, let's go to the next one. Which term of the sequence is this? So the sequence starts something like this: 1, 4, 7, 10. It goes on till 43, or maybe extending that. If this is the situation, let's find out certain objective things. So what is asked for is the Tn, which is given 43. the D here is the difference, common difference between the terms is 4 minus 1 is equal to 3 or 7 minus 4 is equal to 3. If that is the situation, we are being asked the value of n. So let's put it Tn is equal to a plus n minus 1 into d. So 43 is equal to first term is 1 plus n minus 1 into 3. So a bit of a calculation here. 1 plus 3n minus 3 is equal to 43. So this is 45 is equal to 3n. So n is equal to 45 by 3, which is equal to 15. So we are playing around with these formulas only to make our life easier. So I think this much is required, that we know the formulas. Otherwise, it's not AP/GPs. We are doing something else. Let's look at number 6 question. Question number 6. If the first term of the sequence is 2, the last term of the sequence is 44, the number of terms is 15. Find the sum of all the terms in the sequence. First term is equal to 2. The last term 44. N is equal to 15. So the sum of the terms is equal to a plus Tn by 2 into n, or we can write it as n by 2 into a plus Tn, as we have been doing it. So let's do it. 15 by 2 is equal to 2 plus 44. So this becomes 15 into 46 divided by 2. We can easily strike it off as 23. So this is 15 into 23, which is equal to 345. Great. So this is the basic required. Not much of hodgepodge here. Okay. But arithmetic progression is followed by something called as geometric progression. What is geometric progression? Geometric progression is basically a geometric series. What is a geometric series? It's a series where the consecutive terms have the same ratio. A series in which each term is formed by from the preceding term by multiplying it by a constant factor. This constant factor is called as the constant ratio also sometimes, and is formed by dividing any term by the term preceding it. In AP, what we did? We added up. Here we are multiplying. So let's take a situation where A is the first term. We multiply R with this. It becomes AR. We again multiply another R with this. It becomes AR square. We multiply another R with it. It leads to AR cube. Now, this is the first term. This is the second term. This is the third term. This is the fourth term. They are in GP. They are in GP. So let's understand this. Let's take an example. If this is a beautiful one, the sequence is 2, 6, 18, 54. What it is saying? Multiplying it by a constant factor. This ratio, constant factor or ratio, is formed by dividing any term by the term preceding it, that precedes it. So if I divide to find this constant ratio, or R as we call it, it is If I take these two, it is 18 by 6. If I take these two, it is 54 by 18. So this 3 is the number which has been multiplied multiple number of times. So it is basically 2 followed by 2 multiplied by 3, which is 6, followed by 6 multiplied by 3, which is 18, which is followed by 18 multiplied by 3, which is 54. So the number, or rather the sequence that has been formed, is when this first number was multiplied by a constant number. Every consecutive number was multiplied by a constant number. So we arrived at a beautiful formula. Tn is equal to a into, so the nth term in the series. So if there is a series, the nth term, say this is a series, the nth term, say the fifth term, or the say the 50th term, is Tn is equal to a into r to the power n minus 1. Let's take this series. So here the Tn, the nth term, if the series has got, say, the fifth term in the series, we have got 4. The fifth one will be a here is 2 into r is 3 to the power n minus 1. 5 minus 1, 4. So the Tn will be this number. This can be for any GP. The nth term, Tn, is equal to a into r to the power n minus 1, where a is the first term, r is the common ratio, n is the number of terms. Fair? Let's go to the next one, the summation, the sum of numbers in a GP. So obviously a similar situation may arise that the numbers are, say, 2, 6, 18, 54. The sum of the terms in the GP will be Sn is equal to a into r to the power n minus 1 divided by r minus 1. So this, in this case, this will be 2 into r3 n, say, first 10 terms, minus 1 divided by r minus 1, 3 minus 1. Till infinity, one addition, s infinity is equal to a by 1 minus r. Let's involve ourselves with a few questions, so that will make it way more easier for us. Okay, let's take the first question. That will, the endeavor is to have a better understanding of the entire thing. So question number 1 in GP, this goes something like this: that the first term find the sum of the first 10 terms in a geometric series whose first term is 3, the common ratio is 2. So the first term here is a is equal to 3, r is equal to 2. We know the formula, Sn is equal to 3 into 2 to the power 10 minus 1 divided by 2 minus 1. This is nothing but Sn is equal to a into r to the power n minus 1 divided by r minus 1. So this is the formula we have used. So this is 3 multiplied by 2 to the power 10 minus 1. So this will translate to 2 to the power 10 is 1024. 3 multiplied by 1024 minus 1, which is 3 multiplied by 1023. So if I do a simple calculation, it becomes 6. This is the answer. Similarly, let's take the next one. Which term of a GP, this one, is this? So we are asked for to find out the nth term, Tn. Remember, so the second question goes something like this. The series is 4, 8, 16, like this it is going. So we need to find the common ratio. R is equal to 8 by 4, which is equal to 2. Tn, the formula is A into R to the power n minus 1. Here Tn is given 4096. A is 4, we know the first term is 4, multiplied by R is 2, 2 to the power n minus 1. Here we need to find out the n. So let's do a simple calculation. If I take it as 1024 is equal to 2 to the power n minus 1. So we know 2 to the power 10 is 1024. So 2 to the power 10 is equal to 1024. Some we know. So obviously this is 2 to the power 11 minus 1, which is equal to 2 to the power 10 is equal to 1024. So n here is 11. So the 11th term is 4096. If the GP is 4 followed by 8 followed by 16, means a multiplication of 2. Let's take the third question. Find the 11th term in a GP where, okay, the same question rephrased. Tn is equal to 4 into 2 to the power 11 minus 1. What is the 11th term? So Tn is what we need to find out. So Tn is equal to 4 into 1024. So this is actually 4 into 2 to the power 10. 096. Tn is equal to 4096. Look at this. So reframing the two questions actually using the same formula. Okay, and now let's take a twist here. A real 700 plus GMAT question. No? Question number 4. The second term in a GP is 1000. The common difference R is 1 by n, where n is the national number. Pn is the product of the n terms of the GP, and if P6 is more than P5 and P6 is more than P7, find the sum of all the positive values of n. Well, now looks difficult, but it is not that kind of a question which really will be difficult. Let's see. The fourth question. The second term is 1000. R is equal to 1 by n. And product of the n terms is given as Pn, where P6 is more than P5 and P6 is more than P7. So let's break it down. The first term is equal to, say, A. The second term will be A into R, 1 by n. So this is A by n. The third term will be A into 1 by n square. So A by n square. So P5, that is the fifth term, will be If I look at this process, a into 1 by n into 1 by n square plus into 1 n sorry a by uh, 1 square, yeah, what by 1 second, let me just rub it off with this, yeah, yeah, a into a by n into a by n square multiplied by a by n cube multiplied by a by n to the power 4. This is P5. Similarly, P6 will be, so this is actually, there are 1, 2, 3, 4, 5 A's. A to the power 5 divided by n to the power 10. P6 will be a to the power 6 followed by n to the power 15. Similarly, P7 will be a to the power 7 followed by n to the power 21. Now we are given one thing, that is, I'm writing it here. P6 is more than P5. So that means A6 by n to the power 15 is more than A5 by n to the power 10. If I do a simple calculation, I find that A is more than n to the power 5. Just this much. This is what I derive. Similarly, if P6 is more than P to the power 7, that means a to the power 6 by n15 is more than a to the power 7 divided by n to the power 21, which means n6 is less than a. So these are the two derivations which we get. If I sum it up, it goes something like this, that n to the power 5 is less than a, which is less than n to the power 6. Let's divide the entire thing by n, then it becomes n to the power 4 is less than a by n, which is less than n to the power 5. Now remember, this a by n is actually 1000. So it goes something like this, n to the power 5 is less than 1000 is less than n to the power, sorry, n to the power 4. 1 second. Let me write it straight. So coming from here, n to the power 4 is less than a by n is less than n to the power 5, which makes it n to the power 4 less than 1000 less than n to the power 5. So sum of all possible values. Find the sum of all possible values of n. 4 plus 5 is equal to 9. Sort of a question which will not happen in GRE for sure. But GMAT, we find this kind of a bit of a twist somewhere here and there. Okay, so let's knock off our learning by the last bit. The arithmetic mean of a number is always a plus b by 2, and the geometric mean a plus b by 2 is arithmetic mean. The geometric mean is ab whole square. One important bit, if you pick three consecutive numbers, the middle one is the GM of the other two. Three consecutive numbers, say it is 2, 3, and 4. This is the GM of the other two. With this much bit of understanding, our fundamentals are cleared. Thank you very much. So that brings us to the end of AP and GP fundamentals.